So, hello everyone. My name is Muhammad Khalafallah, and currently I work as a research assistant in the Department of Civil Engineering at Auburn University. Right now, I want to in this presentation, I want to describe the in this presentation, I would like to describe the steps followed to create a cost-based lump sum project selection framework for design, bid, build, resurfacing projects. So before we start, let me just say this research project was based on the data that we acquired from Florida Department of Transportation, or what is called as FDOT. So the outlines of this presentation is going to be, or what I call it, the sneak peek of the presentation. We're going to have a small introduction about what is design bid build in general. And then also we're going to talk about the states and the DOTs that has or already developed some guidelines of how to conduct the different techniques of DBB. And then we're going to talk about the methodology and the results obtained from using that methodology, and what are also the how we develop the nomogram at the end. Finally, we're just going to talk about the limitation and the future research that we think is applicable in this area. So let's just start. So design bid build. What is design bid build, or what we all refer to as DBB? In design bid build, usually the design of whatever project is fully accomplished by the owner. So in our case, by FDOT, or is either in-house or by hiring a third-party consultant. And the construction is awarded in a separate contract. So why are we conducting our research in this specific area, or why DBB specifically, and not using the other delivery methods like the design build? Right now, DBB is still the most used delivery methods by DOTs, with more than 70% of the project right now is being procured or contracted through DBB, either using unit price or lump sum. And one thing that I should mention also is most of the research that was published in this area in general focus on comparing DBB with other techniques like design build or construction managers at risk. But nobody actually, I shouldn't say nobody, but not that I've seen that people are comparing the techniques within DBB. So types of DBB that are discussed in this study are unit price, where the compensation is based on the actual amount of work performed. So what we call also a cost per unit contract base, or itemized, which is the mostly used compensation approach right now, especially with DOTs. So they would use stuff such as per cubic yard for excavation or linear foot for guide rails. The other type is the lump sum, which is a fixed amount of money paid for the project. So the contractor will submit his bid, not as just a one lump sum amount, contrary to the unit price, which is going to be broken down into item by item. Why do agencies or DOTs use lump sum? I mean, the main reason is because it reduces the contract administration efforts related to verifying the quantity, and will relieve the inspectors to do more job related to quality verification. So objectives of our study are to develop a methodology to objectively identify design bid build projects that would offer better value for money if executed using lump sum compensation provision. It actually tells you also in a simple words that if you are using lump sum, or if you want to use a unit price, what are the best ways of doing this? Or what I would should say, the most objective way of choosing between those two compensation approaches when we're deciding which resurfacing project we should use. So when we surveyed all the states in the US, we found that only 6 states that have developed guidelines to govern the use of lump sum contracting. And these states were Florida, Michigan, Colorado, California, and Alaska. And Texas was in the process of developing the guidelines, so we have to count it in. So probably by the time I made this presentation, they already developed the full guidelines. We found also another 2 states that they developed guidelines for lump sum, but not for all the projects, but only for projects that are related to traffic control, like pavement marking, signaling, stuff like that. So lump sum, what are the advantages of using lump sum? It reduces the contract administration efforts by the owner, because it relieves the owner in the beginning from doing a very detailed design. Also, it simplifies the payment process since it's just a single payment. It can just be broken down into work progress. And also it allows inspectors to focus more on quality since they're not gonna do any quantity verification. It also has flexibility, gives more flexibility to contractors to select the methods and means to do the actual construction. So what are the disadvantages is difficulty in pricing changes since there is no itemized, there's no items for the work tasks that are included in the project. So if there's something like they want to add to the project, it's going to be very difficult. It also difficulty in identifying extra work, since you wouldn't know how big the project is, or like based on the actual conditions in the site, if there is extra work that is needed, it's not easier to do. Of course, we would know that contractors would probably gonna have higher contingencies in their price proposals since they have a lot of uncertainties to account for. Lastly, it requires a higher design quality. Since in the beginning, if you want to reduce the contractors to have lower contingencies, you should provide a very high quality design, so they would be able to find every piece that they can at least put a price to. So most of the states that we surveyed, I should say the 8 states, the 6 that have developed the guidelines, the full guidelines, and the other 2 states that developed the guidelines for the traffic controls, they all agree on these criteria to select projects for lump sum. So they all said that they only choose projects that are well defined in the scope of work for all the parties included in the project. And also they would only select project that has low risk for unforeseen conditions, and also low possibility for scope changes during all project phases. Lastly, they also select projects that has low possibility for contractors to provide less than the required quantities of work. You want to make sure that whatever you're paying for something that was done, not paying just extra money. So examples of lump sum projects that they use. So they said the most suitable would be, as we said, simple projects. They're like bridge painting, fencing or guide rail, intersection improvement, landscaping, simple milling and resurfacing, minor road widening, signing and traffic marking, simple transportation enhancement projects. So the least suitable would be stuff that has a lot of unforeseen conditions or a very high possibility for change during the project, which would typically be like urban construction or reconstruction projects, also rehabilitation of movable bridges, for example. A project with subsoil earthwork, since anything subsurface, anything that you cannot see, like subsoil earthwork, you would not know what are the conditions beneath that soil. Also, concrete pavement rehabilitation, major bridge rehabilitation and repair. So the methodology followed to conduct research or to come up with the model or the framework at the end, where we used database in the beginning from FDOT project database. These data were from January 2015 and March 2017. The number of projects that we found that are like 1,275 projects, it was divided into 705 unit price projects and 200 lump sum projects. So the steps were like this. So after we conducted the literature review and we collected the data required, so we started the data cleaning process. We extracted all the relevant data from resurfacing projects. Then we went to the data analysis process. The data analysis was comprised of 4 main steps. We developed deterministic cost estimating models using nonlinear regression. And also we developed what we call a cost growth model for both lump sum and unit prices. So we developed a stochastic cost estimating models. And then we joined these both. We joined the stochastic models with the deterministic model, and to come up with at the end, the nomogram. And so the data cleaning process was we only picked projects that was scope of work exclusively focused on resurfacing activities. So any other types of work that is not resurfacing was discarded. So we picked only completed projects where the final payment was made to the contractor. So we would know the actual cost of the project at completion. Also, we selected only projects with the uniform road cross-section along the project to facilitate the calculation of the construction cost per lane. So any like lanes that looks like this, that has, let's say, that the road cross-section is not uniform, we will discard right away. So as an example of some of the roads that we included in our study, look at these pictures. Like this is an interstate. I think this is the I-75, if I'm not mistaken. And like this is one of these rural roads. You can see it's very uniform. So the data that we collected, we divided all the data points by the number of miles for each project. And we came up with an identifier called a per lane mile project. So if the project was like 40 miles, but it has 2 lanes, we would then call this project an 80 mile. So 40 times 2. So this is the data we plotted for the unit process, and this is what we plot for the lump sum projects. So we have these regression equations based on the trend lines of both data points. So when we plot them together, the both trend lines, we came up with this. So if you look at this figure, you would think that it is good to use lump sum if you have a project between 0 miles to approximately 21 miles. So then we went ahead and developed the cost growth model because we want to add a stochasticity part to our model, since these projects are not the cost of these projects is not always the same. So the stochasticity part in this in this model is the change of cost at the end of the project. So we use this equation is to get the stochasticity part for each project. The actual cost measures minus the original cost divided by the original cost as a percentage. So we developed a probability distribution for both of them. So for the unit price, we found the probability distribution to be a normal distribution, and for the lump sum project would be extreme value minimum distribution. When we plot them together, it looked like this, just to illustrate. So for the stochastic cost estimating models, what we did is, so we had our equation. This is the first part. It is the deterministic part, and we added the stochastic part to it on the other side. So where x is the number of lane miles, and n, for example, it's the normal distribution. So what we see between the brackets is actually the mean and the standard deviation. So this part is the unit is the deterministic model, and this part is the cost growth model. We did the same thing for lump sum. Of course, in the lump sum, we said the distribution of the data was found to be extreme value distribution. Let's just make sure this is not the data itself. It's just the percentage changes of the cost for each project. So what we did, we developed a cost comparison. So we plotted these data, or we generated, I would say, 50 projects, 50 random projects that are like ranging from 1 mile to 50 mile. And we ran simulation for the stochastic part at 10,000 iteration for each project. So the number of simulations we did is actually 50 times 10,000. So with the PERT. So we came up at the end with this probability distribution. So we found it didn't change that much from the deterministic model, because in the deterministic model also we said after 50, so the 50%, it's when you would prefer to use the unit price instead of lump sum. And it was found also the same thing as 21 miles at that point. But we wanted to develop a nomogram just to give a scenario, because it's not just like black and white. If you have a 21 miles or above, you just use a unit price, or below, just like lump sum fixes that. We know it has a probability distribution. So we developed a nomogram that the inputs to that nomogram is the number of miles and the confidence level that they want to use. The output of that, it would be the probability if unit price estimate or project cost is more than the lump sum. And we'll also give you what are the expected case scenario, worst case scenario, and best case scenario. So the nomogram looks like this. For example, if you look at the example highlighted in red, is we have a hypothetical project of 20 miles, and you just go vertically straight if you wanted. We said like let me just back up a little. We said the inputs are the number of miles and the confidence level. So if we decided to use a 20-mile project and a 75% confidence level, we would have a project that will save us $13,000 per mile, or we would lose $11,000 per mile. So that's what we developed in this research project. So the limitation of this research is actually, it's only applicable for resurfacing project only. It also assumes the quality. So it assumes the same quality was for all projects. So the cost performance was done using only construction cost. So the future research, this study, we recommend that the study of additional project areas affected by provisions such as design quality, design cost, and administration and inspection cost. Also, develop such models for other types of work and not just for resurfacing. For resurfacing, of course, it was kind of easier to do because we came up with this identifier, what we call the lane mile. But I think we might be able to do the same thing for other types of works. So that's it, guys, for this presentation, and thank you for your attention. And if you have any questions, just shoot me or write me an email. Thank you very much.